of our galaxy, in fact the universe, 99% of all matter is plasma. So we have the sun at the centre of this bubble, and around it is a big energetic bubble called the heliosphere, and it forms a kind of protective energetic membrane around our star system as it moves, so that the cosmic particles that we interface with, the plasma, is largely deflected by the energetic matrix of the sun itself. Well, this is normally the case, but as you can see on the front here, there's this bow shock, which is this wave of compressed plasmic energy, which is on the front end of the heliosphere. Now, NASA has shown that this has increased by 3 or 4 times over the last 10 years. And the amount of plasma actually now seeping into the solar system has increased tenfold. So what we're seeing on the big scale, we're seeing, okay, like extinction and evolution events happen over a scale of hundreds of millions of years, and they're kind of remorseless. You know, they're absolutely, it's not the case that we can just say, okay, well, we're not going to participate in this anymore. It's something which we are a product of. So, you know, we're here because of this evolution process. And we're here because of the extinction process. You know, it's the dinosaurs and us. You know, their extinction, our evolution. This is 2 aspects of one thing. So, what's interesting about this is that this is much more than micro timescale. So, we're seeing very substantial changes caused by what's called the interstellar space medium that we're moving through. And the myth that the space is empty is finished, it's over. That was basically a nice convention that really sat nicely when you thought the sun was being the centre of everything, which it isn't. So the Russian science has looked at various different changes, which they say is directly caused by the inundation of plasma into the heliosphere. So they've looked at the different planets, and they said on Venus you've got, in the last 10 years, an inversion of the dark and light spots, very fundamental change, sharp decrease of sulfur-containing gases in the atmosphere. The Moon, what you've got is first stages of natrium atmosphere generation, that's sodium-based. It's large, it's like 5,000 miles or more in height around the Moon. So effectively the Moon's getting an atmosphere. Mars, significant melting of polar ice caps, changes in the atmosphere. Jupiter's doing all kinds of things. It's really a dynamic planet. It was impacted by a comet in the 90s called Mark Heley, and since then, basically we've seen a doubling of the magnetic field and increased plasma generation. So more energy is coming out of Jupiter than previously was happening. And there's this thing happening between Jupiter and its moon Io, which is just a trip, which is basically there's an ionic flux tube, which is kind of an electrical circuit that connects the moon Io with Jupiter, and it's like this huge current that basically we've just discovered. Saturn, you've seen an increase of plasma coming in, that is demonstrated by these auroral displays, and it's gotten brighter. Uranus and Neptune have both shifted their magnetic poles by more than 50 degrees in the last 10 years. So you're seeing basically pole shifts, magnetic pole shifts on both of those planets, which are Uranus and Neptune are both magnetically conjunct as well, so they're actually related. Their magnetic fields are basically sharing information. So it's not just change on this planet. You know, we can look at, say, climate change. Now, the thing about climate change is that at the moment, most scientists are trying to explain climate change using 2 things. One of which is basically the observation of the Earth's atmosphere, and the other one is basically computer modelling. So they look at the atmosphere, they try and see what's changing, and then they use a computer to model how that will play itself out. And the issue with that is that what it's not looking at is the influence of the sun on our planet. Now, if the sun goes out, we don't have life on the planet anymore. So the sun is really, really important thing. And if you actually look at NASA and their heliophysics division, who are people studying the sun, what they say is the sun is a major driver of the climate. And there's also very good research by an astrophysicist called who studied meteorites that landed on our planet over the last 500 million years. So literally went around and recorded like the composition of these samples, and what he determined was that the major driver of climate on our planet is our position in the galaxy. So, you know, this is a very, very different model from the contemporary science. And the Russian science is basically saying These things are happening, they're causing changes on our planet, they're causing changes all the planet, and they're causing changes in the sun too. And it's basically, getting aware that this is all happening because we're moving. And we're moving into a different area where there's a higher energy. In kind of New Age terms, you can call this is like a parallel to something called the photon band. It was like talked about in the 90s. It was like a channel idea that like the Earth and the Sun moving into a higher vibrational energy. It's kind of funny because a lot of ideas that aren't scientific that are coming through channel sources and New Age books, scientists look at it and say that's wrong, that's impossible. But the photon band, or photons don't do that for a start, etc. They're not, there's no evidence. But actually, the reason that they're pervasive myths and that people really catch on to them is because they're articulating processes which are actually happening. So it's not a photon band, but we're moving through different striations of plasma, and that's basically a plasma band. So there's real direct parallels. So this is the old model of the solar system. The sun's at the centre, and you've got these 9 planets, and they do their thing, and they go around, and that's all fine and dandy. It's going to stay that way until an infinitely large period of time that we can't really care about because it's so many billions of years into the future. Unfortunately, this has already collapsed, and one really key thing, out of all of this stuff that could have gone unnoticed, that I really point attention to, that is like a key thing in this collapsing worldview, is about Pluto. How many people remember about Pluto being downgraded? Yeah, so most people have heard about this. It's a funny decision. The astronomers get together and they say, we've had this planet Pluto for, since we discovered it, and we decided it's not. It's another thing. That's called a dwarf planet. Why do they do that?
Because it's not the biggest thing in its orbit.
It's not the biggest thing in its orbit. It's the argument technically is that it doesn't clear its own orbit. That was the definition of what a dwarf planet is. They categorised it as a dwarf planet, but it's still a planet. A dwarf pea is still a dwarf human is still a human.
It doesn't dominate its orbit, that's the reason.
Well, the argument is that technically it doesn't clear the orbit.
What does that mean?
Basically, planets, inverted commas, are meant to basically sweep the debris out of the orbit. In fact, they don't. What they do is they push them into something called Trojan and Lagrange points, which are basically like gravitational pockets in the rest of the orbit. It's technical and not really that relevant. Basically, the reason they did it was because of these other planets that were being discovered. In fact, there are so many planets being discovered in our solar system, they really needed a new category. These are some of the planets in our solar system. Now, these are dwarf planets, but they're planets. You can't see it very clearly because it's not super focused. But a good trivia question, that should be in the pub trivia quizzes. How many planets in our solar system?
8.
Well, originally there was 9, but I'm going to contend that there are more. Any guesses? 16. Because there's that many dwarf planets. Like, for instance, some of them you probably haven't heard of. Sedna. Anyone heard of Sedna? Cool, good. That's a great planet.
That's only 16 then. That's loads more than that.
Well, there are loads more bodies, but I'm talking about planets and dwarf planets. Because those are tidal planets. There are asteroids, there are other bodies, there's a lot more stuff going on out there. But basically what I'm talking about here are planets and dwarf planets.
How big are these guys compared to, if Pluto's a dwarf planet, how big is Pluto compared to these guys?
Well, the second one from the left in the top row is, originally was called Xena, after the warrior princess, and it's now been recategorised Eris because it has a very eccentric orbit, which means it goes out a long way, it's very elongated. It's bigger than Pluto.
Which one's second from the left? Yours?
On the top,
sorry.
yeah, that's Eris. So Sedna is the next biggest one. Sedna is a very unusual planet. Basically, its orbit is the most eccentric that we've ever discovered. And we were really lucky to discover it because basically what it does, it moves from just beyond the orbit of Pluto to 1,000 times the distance of the orbit of the Earth around the Sun. That is a fantastically far distance out into the solar system. And the people that discover us is basically the Lowell Observatory in the US, And they have been responsible for discovering a whole bunch of stuff which basically lies beyond Pluto. This one is particularly unusual because it goes so far out. But you've got a whole bunch of planets there, and some of them are, you know, like really not that well known. Like there's Orcus, there's another one called Varuna, Makemake. You know, these are planets in our solar system. But what I'm contending is that the old model of a static and stable solar system disappeared when Pluto was downgraded, because it isn't just about these extra dwarf planets that have been added into the story. I mean, we can say confidently there are 7 dwarf planets that have been categorised by the International Association of Astronomers. And I think they included, what was the really, really big asteroid? Is it Vesta? I think it's Vesta was included into that category, which is the biggest of the Mars-Jupiter asteroid belt. But if you talk to the people at Lowell Observatory, what they say is that we're onto a winning streak. We are finding new planets at a rate unprecedented. And we expect to find 30 to 40 of them.
I was just wondering why the first planet's over and the rest.
Yeah, it's a weird shape. You know, that's another thing. I mean, some of these things are just like, I'm really into this, and I really think it's really interesting to actually look at what's out there. There's loads of really cool stuff happening, basically new discoveries of different planets. Stuff that, like, you know, I grew up as an amateur astronomer, and this is like kind of like one of my wildest dreams, really. There's so much stuff out there. So we could have 30 to 40 different planets, including dwarf planets within our solar system. Also, any guesses on how many asteroids have been discovered? This is asteroids bigger than 1 kilometre in diameter that have been discovered since 1980.
There's a lot, and there's a lot more than we thought as well, because we thought that would just be the asteroid belt, and then there's another thing called the Oort cloud. But you talked about Trojan points earlier. Jupiter's got 2 massive Trojan points, and apparently there's more in those Trojan points than in all the asteroid belts.
Yep, and Neptune as well, as you know, major asteroid clouds. There's the potential of ones close to the sun as well. Yeah, basically 1.1 million.
Million?
Yeah. And that puts it in perspective. Now, in terms of mass, it's said that the entire mass of that 1.1 million asteroids is equivalent to 15% of the Moon. But, you know, this is an absolute, like, amazing breakthrough in our understanding of the solar system. And the old model, where we really looked at it as being like, okay, it's a static thing, it remains the same. And the key thing is, like, you know, forget about all the details. The key idea is that previously that we're not influenced by this, that this doesn't matter to us. It's not something which affects our culture. And yet now we're dealing with, like, global problems, global issues. And actually, climate is a really, really good example of that, because at the moment, the IPCC are running computer models which basically simulate the Earth's atmosphere. There is no vector in their model for the influence of the sun. And then if you talk to NASA, what NASA will tell you is the sun determines climate. And Nishabiv's work shows that the galactic cycles determine climate. So we're in a breakdown. The old models don't work, and the new models are basically emerging. So the sun. You know, the sun basically is the most important thing for life on Earth. There's no other parallel. Without the sun, we're dead. So the thing about the sun is that the behaviour of the sun is just not understood at all by modern heliophysicists. Some stuff which has been happening there, it just really doesn't, like, they don't have an explanation for it. A really good example is that there's a sunspot cycle, which is basically the level of intensity of magnetic activity on the sun. And it follows basically approximately 11-year cycle. And usually what happens at the end of the 11-year cycle is that the north and south poles of the sun invert. So there's a magnetic pole shift on the sun. Now that didn't happen at the end of the last cycle. What actually happened is the north and south poles moved to the equator and dissipated. Now that is typical of a chaotic pattern that basically we don't understand. So why is this relevant? Well, sunspot activity and geomagnetic storms have a huge influence on us at the moment. And, you know, our ability to predict these is poor at best. In 2006, NASA said this is going to be a huge cycle, it's going to be 50% bigger than the last one. They got together earlier this year, it was late last year, and they said, we've now we consider this next solar cycle will be low, average in intensity, and we're going to push back the solar maximum. It's going to be sometime in 2013. And that was an interesting one because, like, science isn't done by committee. It's done by theory and argument. And actually, not even all of them agreed about that. There were really massive disagreements about when it would actually happen. There's a new method of predicting solar cycles. It's an interesting one pioneered by these two guys that are down at the Goddard Space Flight Center. They're using these bigger cycles to look at stuff, and they say October 2012, with an error of 5 months approximately. And at 94% effective. Well, I wouldn't listen to them for a moment, because like the last people that said that they were 95% effective were discounted within about 18 months of their theory. But this is like cutting edge. And basically, it's quite interesting because they don't really want to say 2012, because they've all seen the Sony movie, and they don't really want to be associated with it. Yeah, like it's in the ballpark. Basically, the next solar maximum is around the end of the cycle. So, why is this sunspot cycle relevant to us? Well, it directly affects what happens on Earth. We're learning a lot more about how it might affect us by things like this is the picture of the probe called Venus. It's a cluster of satellites that's sent by NASA specifically to measure the magnetic fields of the Earth. And what it discovered was really quite extraordinary. The first thing it discovered was the magnetic fields of the Earth are aligned exactly opposite to the way it was previously considered. And that means that rather than it being a kind of buffer magnetosphere, it's a magnetic envelope around the planet. Rather than being a buffer against the incoming solar storms, it's potentially even an accelerator. So, there's fundamental weaknesses in the magnetic field that weren't expected. Secondly, there's a huge hole in the magnetic field, which is actually 4 times bigger than the planet. The magnetosphere of our planet actually extends out quite considerably. It's an animation. So there's a hole in our magnetosphere, and that's a big deal, because basically that means that if there is really large-scale eruptions in the sun, which does tend to happen at solar maximum, then we're much more vulnerable. To give you an idea of what could happen, there's a report by the National Academy of Sciences in America called Preparing for Extreme Space Weather Events. And what they look at is basically the possibility of there being a very large solar storm which is pointed in the Earth's direction. Now, what they concluded was that it would be likely to knock out satellite systems, and that means GPS, phone communications, mobile phones, the internet. But it also has the potential to knock out large sections of the power grid. And in the 80s, this actually happened in Quebec. There was a major solar storm, and the Quebec power grid went down for a period of time. The problem with a really big space event is that we are extraordinarily dependent at this particular point in our evolution on electrical technology. And for instance, pumps for water in high-rise buildings won't work. You've got to be able to get fuel. Petrol stations don't require electricity. And if there is a major space weather event, I'm not saying at this point that this is inevitable or even necessarily probable, but if it does happen and it was on a once-in-a-century scale, we could be looking at a major series of power outages across the planet that would cause transformer burnout. When transformer burnout happens, that's a real issue because you need power in order to build new transformers. So what they concluded was that with a really big space weather event, we're looking at human civilization taking 4 to 10 years to rebuild. And within the first year, the economic consequences being bigger than the whole of the credit crunch kind of process by a factor. So the possibility does exist And given, if you were to sort of like look at it within a 30 to 40 year scale, you would have to say that some sort of major space weather event is inevitable. And the issue is that we're not prepared for it, because our reliance upon computers, communications technology and electricity is absolutely unparalleled in the evolution of human culture. And it could be simply wiped away in one day. So, this is why this whole thing really, really matters. There are signs also of major magnetic shifts happening on our planet, and that basically what it means is that magnetic poles, north and south poles, are migrating and they're moving at an accelerating rate. Now, that doesn't necessarily mean in the short term that they're going to invert, but they do this periodically. But we're beginning to see the kind of chaotic behaviour in the electromagnetic field that most of the scientists believe does presage some sort of major geomagnetic change. In fact, a whole series of satellites called SWARM were launched this year to actually measure and detect with a great deal more detail the changes in the geomagnetic fields with a view to specifically predicting polar weathers. So this is something that scientists are taking very, very seriously. This is my favourite recent scientific discovery because it's so wacky that no one could have predicted this. Basically, this is something which these probes, Venus and other probes, have detected recently. There is a magnetic channel which directly connects our planet to the Sun. It's about as wide as the Earth in space. But it does this really crazy thing, which is that every 8 minutes it condenses itself into a cylinder and basically punches its way down to the daylight side of the planet at the equator as a magnetic kind of like cyclone. So basically this magnetic portal opens every 8 minutes, huge amounts of hydrogen particles flow into the opening, and no one knew about this. It's basically, you see this artist's kind of representation at the top here, which is like, you can't see it very well, there's the Earth, there's a satellite kind of observing it, and there's this kind of vortex cyclone of magnetic energy, which is like landing on our planet and basically appearing. And these portals appear on the daylight side of the planet around the equator, and then at the solstices, strangely enough, they land at the equator and then they sweep up to the North Pole. And in the summer, they land at the equator and they sweep down to the South Pole. So the key thing to understand here is that the Sun and the Earth are a single magnetic system. That basically we're exchanging information and energy all of the time. And it's not just going one way, it's going both ways. And it's doing it in a way that is so much more complex and so much, has so much more detail than we ever previously understood. And this is all stuff that we're just beginning to understand. So there is this very complex electrical, magnetic communication happening. It's really, I don't really see, you can sort of see that as anything other than communication. It's this profound thing. We don't understand very much of this at all, but it's a recent discovery. What this is about is us coming into an understanding we're part of the system, we're part of a galaxy. And it isn't something abstract, remote, distant. It's something that influences life on our planet on a daily basis because we are subject to the electromagnetic effects of the Sun. There's no way of escaping it. It's something which could affect civilization in such a profound way that we could see our culture fundamentally changed by a single space weather event in a very, very short period of time. And on a much bigger scale, basically, our journey around the galaxy is what determines evolution and extinction. And the remarkable coincidence about this whole story that brings the two parts together is that the next solar maximum is in late 2012 by most predictions. So we have a situation where the Mayan calendrical system, contemporary science, and this emerging awareness of the galaxy are all basically aspects of one thing. And I would contend that that only happens when you're in the middle of a paradigm shift, because when you see the core organising principles of the paradigm, i.e. that we're literally changing our view of reality and that we're changing our centre of the universe, what really is occurring here is basically a fundamental shift from one way of seeing the world, one way of seeing ourselves, into a fundamentally other way of seeing ourselves. And this is a much more expansive and encompassing view.